Hi everyone. Today we are going to discuss regarding week 8 assignment. Okay. So here, what did they do is they have given a data here, which is consisting of different variables and description. The variables are age, estimated salary, and purchase. And these are the this is the description for these variables. So they are saying that uh, they basically have two data sets. One is social network train.csv, social network test.csv. The objective here is to find whether the user buys a product by clicking the ad on the site or not. So data has two independent variables. Independent variables are age and estimated salary. And one response variable is purchased. Okay. And the response variable has two values, that is 0 and 1. Okay. So what do you need to do here is, first of all, I need to read the data sets social network train.csv and social network test.csv as train data and test data. So I've already downloaded this data sets. So if you can see, I'll just show you. What is the social network data set, right? So here you can see here, social network test and social network train. So I have already downloaded those data sets. So now they're saying that you have to read this particular data set train.csv and social network test.csv train underscore data and test underscore data respectively. And here the variable purchase should be considered as factor, not the integer data. So how can you convert this variable purchased as factor data? We'll see. So first of all, let's go here. Go to Art Studio. And I need to read the data set, right? How can I read the data set? That is read.csv. So file name I need to give here. So let's check the file name. It's present in which location? So they told us that it needs to be our trained data. So it's in under downloads. So whenever you are keeping in double quotes, you need to have an extra slash here. The name of this one is social network. Just maximize this one. Social network underscore train dot csv, and this should be read into which one? It should be assigned to train underscore data. Okay, it's read. Let's see what does the train underscore data consist of. It consists of this particular table. Okay, this is our data. So here you can see the description of this one. How many variables you have? You have 3 variables. And is age, estimated salary, and purchased. 280 observations. So totally 280 observations are present in train underscore data, and it consists of 3 variables. Okay. Similarly, you have to read the social network test.csv into train into test underscore data. Right. Let's write that. So test.csv, that will be read into, as you're reading a CSV file, you're just mentioning the CSV command here. Okay, read.csv. So this should be test underscore data. Okay, let's give test underscore data. Let's display it. Let's see the output. So here the test underscore data consists of 120 observation of 3 variables. Okay, totally 120 observations are there. Third variable, 3 variables are present here: age, estimated salary, and purchase. And if you want to check what is the data type of this train and test data, you can just do this way. As you can see, estimated salary is int, age is int, and purchased is int, right? Next, if I do str of test underscore data, I'll be getting the 3 variables as int. But here they told us that the variable purchase should be considered as factor data, not integer data. So how can you convert the factor data into integer data? So let's see. Let me check here. In history, I've already. Okay, it's waste of time checking here. One thing we'll do, I'll just check. How can I convert integer to factor data in R? I forgot the command actually. That's why I'm just checking again. So which particular column you want to convert, that particular column name you have to give here. So this is the one as factor. Let's see whether it's getting changed or not. So here, which you want to convert the this one, train underscore data. So train underscore data, which column you want to convert? The purchase data you want to convert, the purchase variable, right? That's why I'm just saying this equals to, here I am just making it as factor. Train underscore data of purchased. Okay, now if you try to give structure of train underscore data, now you will be getting like this. Okay, you can see the difference here. Earlier it was integer, now it has two levels here. It got converted into a factor with the level 0 and 1. Okay, now we have to do the same with the test data. So here test underscore data dollar purchase, because in test underscore data also you have a purchase variable. I mean purchase column, right? That's why I'm just making it as factor. I'm converting integer data to factor data. Okay, if I do str of test underscore data, now it should be changed to factor. Okay, now it's done. So next what they're saying is, we have done this. So we have to build a KNN model over trained data by considering 3 nearest neighbors. Okay, so for KNN, this is the command. KNN will be taking 4 arguments. One is train data, other is test data, other is CL, other is number of clusters, number of nearest neighbors, you can say. Okay, KNN of train data here. Train data, we already know that these two are nothing but are independent variables. This is not this is the response variable, right? So you need to omit. So totally we have 3 variables. So you have to omit the third variable, that is purchase variable. So how can I do that is, so I'm writing a train underscore data comma -3. So that will be omitted. Similarly here, so here you need to mention which particular column you are going to take into consideration for testing. Okay, that will be considered in CL, that is train data dollar purchased. So in test data also you will be omitting the last column, and here we are going to construct the KNN over the train data. So which particular column you need to consider? The purchase column is the response variable, right? That's why I'm considering this purchase column, because according to this only we are going to build the KNN model, because he already told us in the assignment that This is nothing but in the question that this is the response variable. So you are omitting this response variable and you're considering these two variables only. That's why as I'm omitting this variable, I have to say, I have to use minus sign here because third variable is nothing but purchase variable, right? So how many nearest neighbors you have? 3 nearest neighbors. So I'm going to assign this to predicted underscore KNN. Okay. Okay, I got this one because I have to download this package KNN. So let's see how can we download the package KNN. So you have to install some dependencies here. So one dependency, one package is moment, library underscore caret and library underscore. See, let's Google this error, then you'll get to know. That package is not present actually. The dependency packages I didn't download. So you have to install the package class. Once you download, once you install the package class, then you can just include that particular package, import that particular package and start building KNN. Let's see. How can you do that is I can just say install dot packages of what is the package name, class, comma, dependencies equals to false. Now it has to get installed. Let's see whether it's getting installed or not. Okay, they are saying that the dependency, the warning is that R tools is required to build R packages. So one thing we'll do from here, we'll try to build, import the packages. So let's go to this package and search for this name. So it's already installed. So we're just importing them. And now this also installed. Okay. If you are using our GUI, so you can just type these commands initially here. That is what I have done here. Install dot packages of class dependency equals to false, like that you can do it. Okay. So now let's try to implement KNN. So now you didn't get any error because the package required for this KNN are class and caret. Okay. So this is done. If you do predicted underscore KNN and display, you'll get these all values. Okay. Now what do you need to do? They're saying us that they're asking us what is the accuracy of the model over test underscore data. So to find accuracy, you have to build a confusion matrix over which data. They're saying you further test data, you have to build this. So the command will be in this way. The confusion matrix of data equals to which data you're going to give the predicted KNN and which is the response variable purchased, right? So I'm just going to write it as confusion matrix of data equals to the predicted data, that is predicted underscore KNN comma test underscore data of purchased. Okay. So this will be your confusion matrix. And we are going to store this in some variable called confusion matrix. Okay. If you try to display this one, confusion matrix, then here you will be getting the accuracy and all the details. Confusion matrix in statistics, that will the accuracy is 0.7917, that is approximately 79.17%. Which so here asking the range which this particular accuracy belongs to. So this is the range. So in that way you can find it out. So most probably where you have to build a KNN model and find the accuracy, they will not ask you these questions in your external exam because you need the help of RStudio here, which is not available for external exam. So they will not ask you this question, this type of questions. Okay. So next, total number of misclassified samples obtained from the prediction of KNN model. So here, what are the misclassified samples, right? Misclassified samples are nothing but the false negative and false positive ones. So this will be 14 plus 11, that will be 25. Okay. Predicted and reference value you have to consider, and the diagonal values will be. So this is true positive and true negatives. Okay. So you have to consider the false negative and false positive. Those will be considered as misclassified samples. So 14 plus 11, 25. So that will be your misclassified samples 25. Next, the sensitivity of the KNN model. So sensitivity. So whenever you just do confusion matrix here, once you've already built a confusion matrix for this particular data. And whenever I'm doing this one, whenever I am just trying to print confusion matrix, I'm getting confusion matrix in statistics. From the statistics, you can find the sensitivity value as 0.8293. If I round it off to two decimals, then I'll be getting 0.83. Okay, so this will be your output. So next, consider the wholesale customers underscore data dot CSV, and they're saying which refers to the clients of a wholesale distributor. The objective is to segment the clients of a wholesale distributor based on their annual spendings in monetary on diverse product categories. So these are different categories: fresh milk, grocery, frozen, detergents, papers, and delicacy. And channel and region are different categories. So these are nothing but your products you can consider. So we need to read the whole data set. Okay. And answer this question. Which of the following products is the highest annual spending unit? So how can you read the data is nothing but I've already downloaded the data here. Wholesale customers data. Here you can find it. Let's open it first. I'll just show you what does it contain. So this is the wholesale customers data. So how many column it has? If I remember that it has 440 columns. Okay. And here they're saying you have to find which particular product has the highest annual spending. One thing you can do is you can just sum all these elements. You can find the total sum of all these products and find the highest amount. The other way in RStudio, how you can do it is read the data first, the data set value. Let's see the way it is written. So I want this name of the file. Okay, wholesale customers data.csv. That is read into now wholesale data. Let's give this name wholesale underscore data. So if I just print this data wholesale underscore data, then I'll be getting these all columns. Okay. So here you can see how many columns it's present. So totally 125 plus my 125 data is present. And totally you have here, you can see here 440 observations of 8 variables are present. Okay, here I can view the data. 440 440 observations are present. How many variables? 8 variables. Okay, so now what will I do here is I'll just give summary of wholesale data. Okay, so this will give me the summary, the first 5 values. Okay, 5-point summary here. So if you check the maximum value everywhere, which has the highest value, fresh product has the highest annual spend. So that should be considered as your option here. Okay, because in suppose you got this problem in external exam and you have to do, then you have to do the, what you have to do, you have to solve the summary in this way by taking the sum of all the columns. Okay, take the total of all the columns and then which has the highest spending per unit, you need to check it. Okay, that's how you can do it. Most probably they will not ask these questions, guys, so don't worry. Next, which of the following interpretations are true with respect to the distribution of the variable grocery? So here they are saying that the annual spending of groceries is right skewed, left skewed, or normally distributed. So how can you find it is, here there is so let me just download this package. This is moments. Okay. So there is one proper, there is a command called as skewness, guys. So on which variable I need to apply the skewness? On grocery, right? So let me apply that. So skewness, I'm just saying skewness of the wholesale data, dollar grocery. So here it is positive value. Okay, so whenever you get the skewness coefficient, okay, it is greater than 0, then I can say that it is nothing but positive. The skewness is it is positively skewed. Whenever it is positively skewed, it means that the annual spending of grocery product is right skewed. Okay, whenever this value is less than 0, this value is less than 0, that is, it is negative. If you get a negative value, it means that it is negatively skewed and it is left skewed. If it is equals to 0, then I can say that it is normally distributed. Okay, so here you got a positive value. So now I can say that this is nothing but rightly skewed or positively skewed. So in this way you can do it. Okay, these type of questions you won't get it, guys. Okay, so what is the percentage of customers buying the product for different region? So how can you do that is, you have to consider the region column. Okay, so here they asked what is the percentage of products getting sale from this particular region, Lisbon, Oporto, and others. Okay, so what did I do here is, I went to the Excel sheet. Okay, I went to the Excel sheet and selected the region column. I just checked how many, I just counted what is the occurrence of each regions. Okay, and I have done in this way. Counter countif of which column I need to say, what is the range of that? So I'm going to search for 3. So I got it as 316. I'll just write it here. Of 2. Similarly, of 1. Okay. So this is nothing but 3 is nothing but others. 2 is Oporto. 1 is, what did we say? Lisbon. Okay. So this is what you remember. Now, how many total observations you have? 441 observations, right? So I'm just saying this by 441 into 100 will give us the percentage of this, the products getting sale from this region. Okay. So here this is nothing, and if I round it off, I'm getting a 72%. If I just round it off, this will be 11 and this will be 18, you can say, or 17.5. Okay. So let's check whether we have any options here. Yeah. Lisbon is 18%. So this is, I can say 18, 11 and 72. Others is 72 and this is 12. Sorry, 11. So these are your options. Lisbon 18, Oporto 11 and others 17. So this is how you have to do, guys, without RStudio. So with RStudio, if you have to do, so this will be a command. So you have to find the data of region. Can do the table for this one. So if we do this command, let's see what's going to happen. So I'm just saying table of data, wholesale data of region. So if I do is, I got the same thing, 77, 47, 316. Okay. Let's do the help of this table command. Then we'll get to know what is this. The same thing, it is used to find the occurrences of this one. So what they are doing, they first found the occurrences of each of this. Okay. Once they found the occurrences, they got 77, 47, 316 and divided by the total number of observations. The total number of observations, how can you get it is with the help of this command, that is sum of table, sum of these all occurrences. So if I just write it as in this way, if I do this sum, so I'll be getting 440. So they have done the same thing. They have just by sum of this one they have done. So they got this thing. That's okay. Into 100 they have done. So they have got these values. So this is the command. Okay. Into 100 they have done and they got the region split 18, 11, 12. That's how you can do it. Okay. Next. So here they are saying that segment the clients into 4 groups and you have to build a k-means clustering and you have to divide the cluster into 4 groups. Okay. And you have to drop the variables channel and region and normalize the data using scaling function, and random number generator should be set to 1, 2, 3 by using set.seed. Okay. Let's do these steps, guys. So how can I read the data? I have already read the data. Now I just need to drop the last 2 columns, right? So if I am trying to print this data, wholesale data, if I'm printing, you can see here that the channel and region are getting printed as the first and second columns, right? Okay. It's getting printed as the first and second columns. So I need to drop them. So how can I drop them is just writing wholesale data of -1, -2. So I'm writing minus C of 1, 2 I need to do, sorry. Because you have to drop the collection of the columns, right? So 1, 2. So if I just wholesale of data, or if you just find the structure of this one, you can just find 6 variables now. Okay, milk, fresh milk, grocery, frozen, detergent, delicacy. Channel and region got omitted, dropped. 1, 2, 3, 4, 5, and 6. Now what do you need to do? I need to normalize the data. So how can I normalize the data? Using scale of data. They are already given in this, right? Using scale function. So I'm just saying scale of wholesale data. Okay. And if I just print this one, then I can see. So it got scaled. Now again, I need to set the seed to 1, 2, 3. It's done. After that, I need to build a k-means cluster. Okay. K-means cluster should be built. And here you have to divide the cluster into 4 groups. Okay. So 4 groups they have considered. They are dividing into the 4 categories here. Here they have mentioned 4 groups, right? And so you have to build the k-means cluster using this command, k-means cluster command. K-means is the command, and data cluster. They are storing after building this whole k-means that is getting stored here. And from that, what do you need to do? You need to find out. You need to find out within cluster sum, and next the size of each cluster. And what is between cluster sum of squares, value of k-means model, and what is total sum of squares, value of k-means model. Okay. So let's build the k-means model. K-means of wholesale data, because we have stored in wholesale data, comma 4. Okay. Now this I'm just storing it in wholesale plus wholesale k-means. Okay. Now what I'm going to do? Now I just want to display the wholesale k-means here. Okay. Once I have done here, you can see we got the summary of this one, of the k-means clustering summary. So in this summary, you can find the within cluster sum of squares. I mean sum of squares by cluster. So this is the one you want to display. Okay. If you want to just display within cluster, so how can you display that cluster is nothing but within cluster SS. So this will be the command here. So data cluster within SS. Okay. For size, you can just do $size. And for between cluster sum of squares, you can just do between SS and total SS. We'll do that and see. So this will be your within cluster sum. From the summary also you can get this one. So there, let's check whether we have these options. Yes, we have those options. That is the first one. 440.1481. So this is the first option. Dollar within SS. So this is your data. Now within size, if you do, the size of each cluster you'll be getting. Size of each cluster is 163, 96, 12, 269. Okay, that's why it is B option. Next, what is the between cluster sum of square? So that one you can do it using between 1280.128. Let's check whether we have that range. So this is the range which you need to select for that. Okay. Next is total sum of squares. For total sum of squares, dot SS. Okay. 2634. You need to select the range. 2634 will be coming in this range. Okay. Like that you need to do. So elbow plot can be used to decide the optimal K value in both KNN and K means. Yes. True. Elbow plot can be used to decide the optimal value of both the clusters. Next, the most commonly used distance method to calculate distance between centroid of each cluster and data points is Euclidean distance only. Okay, K-means clustering model becomes better whenever there is a decrease in within cluster SS and increase in between the clusters. Okay, take the solution first. So he is saying that K-means clustering is effective model is effective only when it clusters the data points such that the data points of similar class are closest to each other. So whichever data points are similar, they will be grouped together, and whichever data points of different classes are far, that they will be moving to the other classes. Okay. So according to this, you can say that whenever within the cluster space is decreasing and increasing in between the clusters squares is increased, then you can say that K means is becoming effective. Okay, this is about your week 8 assignment. So if here you can see, they can just give you the summary of this, guys, in this way. They can give you this output, this summary, and they can ask you from this output, what is the within cluster sum of squares from this data, or what is the size of this data. Size they will not ask you because you need an help of RStudio there. Okay. So they can just give the summary and ask you in this way. They can say, somewhere we found this, right? Fresh variables. The highest annual summary. I'll just show you. So here, before scaling only, we have done that. Yeah, here. Summary of wholesale data. They can give you the summary of wholesale data and ask you which of these among products are having highest annual summary. So you have to check the maximum value here. Okay, like that you can do it. They'll give you this output and then they can ask you questions, but they will not ask you in this way where you have to apply the RStudio. Okay, such questions you will not get it. Hope it is clear. Thank you.